Hi, in this video, we're going to take a look at ICMPv6, the echo request and the echo reply messages. Okay, so as far as looking at our informational messages, these are obviously the most common ones or the most well-known. So let's take a look at the echo request and echo reply. So similar to the IPv4, echo request, echo reply, these are, excuse me, ICMPv6 messages used by the ping utility. So the type field is 128 for echo request and 129 for echo reply. The code field is always 0. So the source sends an echo request, or not the source, but let's say PCA sends is pinging PCB, sends an ICMP echo request, and PCB will send an ICMP echo reply. That's assuming that neither PC has a firewall setting or any other setting that does not allow ICMP v6 echo requests or echo replies from being sent or received. Also assuming that we don't have any router along the way that is dropping those. Okay, so here I'm just going to show a simple ping command from PCA, ping in an IPv6 address, send in the ICMP echo request, and it gets a series of ICMP echo replies from that the destination of the echo request, which is router R1. We can actually take a look at what this echo request and echo reply look like in Wireshark. So here we have the IPv6 header, and we can see the source and destination IPv6 addresses. Also, there's a next header field. So that's hex 3A or 58 in decimal. So that means that the IPv6 main header is carrying an ICMPv6 payload. Okay. And we can see in the ICMPv6 type code fields, it's a 128, which is an echo request, code 0, which it says, oh, should always be 0. So this is an ICMP echo request. In the echo reply back from the router, okay, and here we're just, by the way, we are pinging a global unicast address. We'll see what happens if you ping a link local address in a moment. But there's the source and destination address of the echo reply. Again, it's ICMPv6, hex 3A, decimal 58. The payload is ICMPv6, and we see the type field is a 129, meaning this is an echo reply. Now, something you will see in the ICMPv6 message is an ID and sequence number. The identifiers just helps to match a series of echo request messages to their corresponding echo reply, but it matches an entire series. So our ID here, this ID value, will remain constant for the entire sequence of echo requests and echo replies. So whatever so on a Windows machine, if it sends 4 or 5, I should look at that real quick. I should know that. 4, right? Yeah, Windows. Okay, I've been using my Mac too long. So on an echo, let me go back to this. Okay, so on a Windows machine, this ID will be the same for all 4 echo requests and echo replies. Okay. What will change, though, is the sequence number. So the first, the sequence is used to match a specific echo request to the echo reply, or the echo reply to the echo request, I should say it that way. So you'll see here that in the this echo reply has a sequence of 0. The echo request also had a sequence of 0. The next echo request for the same sequence of pings will have a sequence number of 1, and so will its echo reply from R1. Okay, so again, this stays the same for the set of pings. For the, say we have 4 pings sent, echo requests, and echo replies coming back. Okay, this will be the same. The sequence number will be 0 for the echo request going out, and then for the specific echo reply coming back, I'll do it like this, it will also be 0. Okay, this is the sequence number here. The next echo request will have a 1, and the echo reply will have a 1. The ID for all of these will be 0. It's just that the sequence number will change. Anyway, kind of cool. So you can that's how those things are actually tracked. Okay. Pinging a link local address. So if I'm on router R1 and I want to ping the link local address of PCA, okay, it will actually ask me for the exit or output interface. That's because this link local address can exist on any of its interfaces. Remember, we can have the same link local address on multiple interfaces or multiple links, as long as it's unique on that link. There's nothing on the link local address that says where it exists, because these aren't routable. So R1 doesn't know which link we're talking about here. So we have to put the exit interface so it knows which interface to send out the echo request. Well, iOS for some reason complains and says, sorry, but this isn't good enough. I should know what gig 00 is, but they didn't. Well, I won't get into what. I think they've done this, Cisco iOS has done this for a couple of commands, which doesn't really make sense, but they want the complete name of the interface without spaces. I'm sure that's got to change one of these days. And here it says, okay, now I know which interface to send out the 5 echo requests, and I got the 5 echo replies. Okay, so looking at it from Wireshark, again, we see the source and destination. And notice when the destination is a link local address, the source is also a link local address. So it's sourced from the link local address of the router. Okay, and we can see there the type 128 code 0. And by the way, there's our ID field and the sequence number. Okay, here's the echo reply. Again, the reply from PCA sourced from its link local address and to the link local address of the router. Okay, and there's the type 129 echo reply. And again, there's same ID field, same sequence number. The ID field will remain the same for all 5 of these echo requests and echo replies, but the sequence number will increment for each echo request. Okay, what about pinging a link local address from a Windows PC? Let's ping the router. All we need to do is say ping the link local address. Windows says I can handle this. I usually only have one interface on my machine. So it says no problem. If I have both a wired and wireless interface, it will typically choose the one that it thinks has the best connection. Usually it uses the wired connection. Yeah. But we can actually specify that. Remember we talked about the zone ID. So we can actually specify which interface we want to send it out of using the zone ID. Okay. If you want a review of these, look at the video or in my book, the chapter on link local addresses, where we discussed this zone ID or scope ID. Okay, well, how about in Linux? If I say ping 6, which is the ping command for IPv6, it doesn't like it if I just give the link local address. This will work for a global unicast address, but not for link local. So again, I have to give that zone ID or scope ID. I can say either percentage ETH0 to send it out the wired link, or I can say ping6 dash I, the interface, ETH0. So this is my Ethernet 0 wired Ethernet connection, FE8, and then the FE80:3. All right, so that's the ICMPv6 echo request and echo reply. More coming in the next set of videos.